and hit a target within 10 meters? The numbers didn't work. Soviet engineers ran the calculations and kept arriving at the same conclusion. The guidance system alone would require computing power that didn't exist in anything smaller than a refrigerator. Moscow's Navy Day parades in the mid-'80s featured admirals openly dismissing Tomahawk as Pentagon theater. One Soviet naval publication from 1986 called it capitalist propaganda designed to justify bloated defense budgets. They had evidence for. By 1983, Los Angeles-class attack subs were successfully firing Tomahawks from submerged launch tubes during exercises. The missiles broke the surface, ignited, and flew program routes with startling accuracy. But these tests happened in controlled conditions with weeks of preparation. The Soviets assumed combat conditions would destroy that precision. Wind, weather, electronic warfare. Surely something would break the guidance system. Iraqi military planners absorbed Soviet doctrine completely. Saddam Hussein's officer corps trained in Moscow, studied Soviet manuals, built defenses around Soviet assumptions. When Iraq invaded Kuwait passes, nobody in Baghdad was tracking American naval movements with appropriate concern. The U.S. Navy began Desert Shield deployments in August 1990 with unusual quietness about one specific capability. Aircraft carriers got press coverage. Battleships reactivated from mothballs made headlines. But the Tomahawk inventory loading onto Ticonderoga-class cruisers and Spruance-class destroyers didn't generate much public discussion. By January 1991, 52 American warships were positioned in the Persian Gulf and Red Sea, carrying 288 operational Tomahawks. Iraq's intelligence service reported the ship positions, but fundamentally misunderstood what they represented. Saddam's generals saw a naval blockade and carrier threat. They prepared for airstrikes. Their entire strategy assumed war would start with American aircraft crossing their borders where SAM batteries could engage them. The Tomahawk changed that assumption into rubble. The Tomahawk's guidance system combined three technologies that shouldn't have worked together in the 1970s. Terrain contour matching, TERCOM, compared radar altimeter turbulence and weather. The onboard computer had less processing power than a modern washing machine. The guidance maps had to be created from satellite reconnaissance, converted into digital terrain data, then loaded onto tape drives the size of hardcover books. General Dynamics won the contract in 1972 and immediately hit problems nobody anticipated. Early test missiles for lighting differences between reconnaissance photos and actual flight conditions. Missiles that worked perfectly in Nevada testing crashed in simulated European terrain. The program nearly got canceled 4 times between 1974 and 1979. What saved it was Cold War paranoia about Soviet naval expansion. America needed a weapon that could strike Soviet ports and command bunkers from submarines lurking offshore. Strategic thinking in the late 70s assumed World War III would go nuclear within hours. Cruise missiles offered a conventional precision option before ICBMs started flying. Congress kept funding Tomahawk because the alternative was worse. By 1983, the guidance system finally achieved reliable accuracy. The solution involved brute force mapping. Intelligence agencies photographed potential target zones from every angle, every season, every lighting condition. They built massive digital libraries of terrain data covering the entire Soviet Union, Eastern Europe, and every conceivable conflict zone. Each Tomahawk got loaded with mission-specific maps before launch. I don't know exactly how many people worked on creating those map libraries, but it must have been hundreds. The missile itself looked deceptively simple. 18 feet long, 2,000 pounds, fitted with a 1,000-pound conventional warhead or a W-80 nuclear option. Launched from standard vertical cells on cruisers and destroyers, or from armored box launchers on battleships. The booster rocket fell away after 10 seconds, and a turbofan engine took over. Fuel efficient enough to fly 690 miles on the original Block II versions, extended to 1,000 miles on later variants. Soviet intelligence obtained detailed Tomahawk specifications through espionage by 1985. They knew the dimensions, knew the guidance system design, knew the accuracy claims, and they still didn't believe it would work in combat. Their analysis concluded that American test data was exaggerated and actual combat performance. They weren't idiots making wild guesses. Their skepticism was rooted in legitimate technical challenges they'd faced developing their own cruise missile programs. Soviet systems like the P-700 Granite worked, but required much larger platforms and shorter ranges. Miniaturizing everything into Tomahawk's package while maintaining accuracy seemed impossible. Iraq bought that Soviet analysis completely. Their military planning in 1990 included zero defensive preparation for cruise missile attack. The USS Wisconsin and USS Missouri, battleships built in 1944, arrived in the Persian Gulf carrying weapons their original designers never imagined. Both ships had been pulled from mothballs in the 1980s and retrofitted with armored box launchers holding 32 Tomahawk missiles each. These weren't the only platforms. Ticonderoga-class cruisers like the USS San Jacinto carried 122 vertical launch cells. Spruance-class destroyers added another 61 cells per ship. By January 1991, American naval forces had positioned enough Tomahawk inventory to level every critical target in Iraq without flying a single sortie. Iraqi intelligence knew American ships were out there. Their reconnaissance reported carrier groups, surface combatants, amphibious assault ships. But Saddam's commanders interpreted this as each target got photographed from multiple angles, mapped digitally, assigned GPS coordinates accurate to within meters. Tomahawk mission planners created flight paths that exploited terrain masking, routing missiles through valleys and around populated areas to minimize detection time. This wasn't just picking targets on a map. Each missile's route had to avoid known SAM batteries, points programmed into the guidance system. The Navy spread the Tomahawk platforms across 2 launch zones. Northern Persian Gulf positioned ships within 400 miles of Baghdad. Red Sea forces operated further out but could still reach targets in western Iraq. This geographic dispersal meant Iraqi defenders couldn't concentrate their response. Missiles would arrive from multiple directions simultaneously. Something people don't talk about enough. The logistical insanity of loading 288 missiles onto warships while maintaining operational security. Each Tomahawk required mission-specific programming loaded via data cassettes. Every missile had to be inspected, tested, locked into launch cells or box launchers, then kept at readiness for weeks while diplomacy played out. One malfunction could abort a launch sequence. One guidance system failure could send a missile off course into civilian areas. American ordnance crews got it right. All 288 missiles reported ready status by January 16th. Iraqi military intelligence somehow missed the strategic significance. Their daily situation reports from January focused on coalition aircraft buildups in Saudi Arabia, counting F-15S, F-16S, A-10S, British Tornadoes, French Mirages. Saddam's air defense commanders positioned their SAM batteries to counter high-altitude bombing runs. They laid out AAA concentrations around likely aircraft approach routes. Their entire defensive plan assumed war would start with American jets crossing the border at 25,000 feet, where Iraqi missiles could engage them. The battleship USS Missouri sat in the Persian Gulf on January 16th with 32 Tomahawks programmed and ready. Its crew had trained for this moment without knowing exactly when it would come. The missiles in those armored box launchers represented 50 years of American engineering evolution, from the inaccurate cruise missiles of the 1950s to precision weapons that could fly through a warehouse door from 600 miles away. Baghdad's air defense network had 10 hours of peacetime left. The first Tomahawk launched from the USS Paul F. Foster at 3 a.m. Baghdad time on January 17, 1991. The booster motor lit and the missile climbed vertically from its launch cell, then pitched over toward Iraq and leveled out at cruise altitude. 30 seconds later, another missile launched, then another. For the next 3 hours, American warships fired Tomahawks in carefully timed sequences, designed to overwhelm Iraqi air defenses through sheer simultaneity. Nobody on those ships had done this before. Tomahawk had been fired in tests and exercises, but never in actual combat with live warheads aimed at real targets. Each launch was a gamble that the guidance system would work as designed, that the terrain maps were accurate, that weather conditions wouldn't interfere with DSM-AC cameras. The missiles performed flawlessly. Iraqi radar operators started detecting unidentified contacts around 3:15 a.m. The returns looked wrong. Too slow for aircraft, too low contacts to their command centers, and waited for orders that never came, because the communication network started dying 20 minutes later. Tomahawks hit Iraqi air defense headquarters and command bunkers first. The targeting priority was deliberate: blind the network before destroying individual nodes. One missile struck the Iraqi Air Force Operations Center in Baghdad, with enough precision to collapse the building's central section, while leaving adjacent structures mostly intact. Another blew through the roof of a communication facility and detonated inside, severing landlines connecting Baghdad to regional air defense sectors. The USS Wisconsin fired 24 Tomahawks in sequence. I've seen Navy footage of those launches, and the visual is almost surreal. This massive battleship with 16-inch gun turrets, surrounded by modern technology, firing missiles that looked tiny compared to the ship's scale. Each launch produced a bright rocket plume and a pressure wave that rippled across the deck. Crews wore hearing protection and stayed clear of the launch boxes. Missouri's launches came 40 minutes later. Both battleships had positioned themselves for optimal flight paths into Baghdad, close enough to reduce flight time, far enough to stay outside Iraqi patrol boat range. By 4:30 a.m., 116 Tomahawks were airborne simultaneously over Iraqi territory. They flew different routes at different altitudes, but converged on targets within minutes of each other. Some missiles followed highways at 200 feet altitude before breaking away toward their targets. Others used terrain masking in river valleys. A few flew directly over Iraqi army positions. Soldiers saw them pass overhead and mistook them for low-flying coalition aircraft. Iraqi SAM batteries tried engaging the missiles. SA-2 and SA-3 systems fired dozens of missiles at Tomahawk contacts. Almost none connected. The cruise missiles were flying too low and too fast for radar systems designed to track bombers. Mobile AAA units had better success ratios, but still only managed to shoot down maybe 4 or 5 missiles during the entire opening attack. The attrition rate didn't matter. Even if Iraq had destroyed 20% of incoming Tomahawks, 230 missiles would still have hit their targets. Presidential palaces, power stations, communication towers, they started exploding across Baghdad before most residents understood what was happening. Some people thought the attack was coming from aircraft they couldn't see. Others assumed ballistic missiles. Very few immediately recognized cruise missile strikes because the concept was too unfamiliar. American naval crews reloaded launch cells and prepared for follow-up strikes while the first wave was still hitting targets. Iraqi air defense doctrine was built entirely around the threat model Moscow taught them. High-altitude bombers approaching at 20,000 to 40,000 feet, giving radar operators 10 or 15 minutes of warning time to calculate intercept solutions and launch SAMs. The system worked beautifully in exercises. Iraqi crews trained for years against simulated American bomber profiles, B-52s, F-111s, F-15S Strike Eagles coming in at medium or high altitude where radar coverage was strongest. Tomahawk missiles flew at 50 to 200 feet depending on terrain. This altitude made them effectively invisible to most Iraqi early warning radars until they were almost on top of their targets. The radar horizon for ground-based systems meant a missile flying at 100 feet couldn't be detected beyond 15 or 20 miles under ideal conditions. In practice, terrain obstacles and urban clutter reduced that to maybe 10 miles. Iraqi operators got 60 to 90 seconds of warning before impact. You cannot successfully engage a target in 90 seconds when your system needs 3 minutes to calculate firing solutions. SA-6 batteries had the best theoretical chance. They were mobile, designed for low-altitude threats, and could traverse quickly. But SA-6 operators trained against aircraft that maneuvered, that tried to evade, that gave you visual or radar signatures to track. Tomahawks flew straight toward their targets at constant speed, with minimal radar cross-section. The missiles didn't dodge or deploy countermeasures because they didn't need to. By the time an SA-6 crew locked on and fired, the Tomahawk was already past them or seconds from impact. Baghdad's integrated air defense network collapsed in the first 30 minutes. Command centers went offline. Communication landlines got severed. Regional air defense sectors lost contact with central command and reverted to autonomous operations, which meant local commanders made independent decisions with incomplete information. Some batteries kept firing at anything that appeared on radar. Others shut down to avoid American anti-radiation missiles they assumed were coming. The anti-radiation missiles came later, but Iraqi crews were already paranoid. I think the psychological impact was worse than the physical damage initially. Iraqi operators knew their equipment, trusted their training, believed their defensive network could handle American air attacks. Then cruise missiles showed up flying profiles their systems couldn't effectively counter. It's one thing to get overwhelmed by superior numbers. It's different when your entire operational doctrine is suddenly obsolete. Power stations across Baghdad started going dark around 5 a.m. Tomahawks hit transformers and switching facilities with precision that left residential areas mostly intact while crippling the electrical grid. The 1,000-pound warheads weren't subtle. They obliterated targets through overpressure and fragmentation. One missile hit a communication tower, and the structure folded in half. Another punched through a reinforced bunker roof before detonating inside. Some Tomahawks malfunctioned. Guidance systems failed, engines quit, waypoints got corrupted. Maybe 15% of launched missiles never reached their targets. But the American targeting plan accounted for attrition. Critical targets got assigned multiple missiles to ensure destruction even with failures. The Iraqi military had prepared for chemical warfare, for armored assaults, for urban combat, for prolonged attrition. They built bunkers deep underground, dispersed their forces, stockpiled ammunition. None of it mattered when your command infrastructure gets deleted before you understand what's attacking you. Coalition aircraft started crossing into Iraqi airspace at 6 a.m. By that time, Baghdad's air defense network was already blind, deaf, and operating in isolated fragments. The Tomahawk strikes had accomplished their mission, paralyze command and control before the real air war begins. Iraq's military was still dangerous, but it was fighting without coordination or central direction. 288 Tomahawks launched during the first 24 hours of Desert Storm. 245 hit their assigned targets. That's an 85% success rate under combat conditions, a number that shocked even American planners who expected closer to 70% effectiveness. The targeting list read like a blueprint for dismantling a modern military. Presidential command bunkers, including the Al-Faw facility buried under 30 feet of reinforced concrete, destroyed. Iraqi Air Force headquarters in Baghdad, mission killed with 3 direct hits. Communication nodes connecting Baghdad to regional commands severed. Power generation for military facilities offline. The Tomahawks systematically deleted Iraq's ability to coordinate defensive operations. Battle damage assessment came from multiple sources. Reconnaissance satellites photographed impact sites within hours. Special operations teams on the ground confirmed destructions. Signals intelligence monitored which Iraqi communication networks went silent. The evidence was consistent. Tomahawk strikes achieved their objectives with accuracy nobody outside the U.S. military believed was possible. One missile hit the Ba'ath Party headquarters with such precision it collapsed the building's central structure while leaving adjacent government offices standing. Another struck an underground command facility and penetrated deep enough to cause internal detonation. Survivors described the entire bunker system shaking like an earthquake hit it. A third took out a communication tower by hitting the base supports, and the entire structure toppled sideways into an empty lot. These weren't area bombardment weapons. These were surgical instruments used like sledgehammers. Iraqi damage control teams couldn't keep up. They'd respond to one destroyed facility, and another would explode 2 blocks away. Civil defense crews had trained for air raids with warning time, sirens, shelters, organized response. Tomahawks gave no warning. Missiles appeared without aircraft engine sounds. Without bombing runs you could track visually. Just sudden explosions. The few missiles that missed their targets failed for predictable reasons. Guidance system malfunctions caused 3 or 4 to crash in unpopulated areas. One missile's TERCOM got confused by terrain changes not reflected in its digital maps and flew in circles until running out of fuel. Another lost GPS signal lock and reverted to inertial navigation, which accumulated enough drift to miss its target by 200 meters. 15% failure rate still meant 245 successful strikes. American targeting officers had prioritized each facility on the list by strategic value. Losing one bunker wouldn't cripple Iraq's command structure, but losing 30 bunkers simultaneously did. The Tomahawk campaign wasn't designed to win the war alone. It was designed to blind, deafen, and paralyze Iraqi command, so coalition aircraft could operate without coordinated resistance. That mission succeeded completely. By dawn on January 18th, Saddam Hussein's military was operating in fragmented chaos. Individual units still had functional equipment and motivated personnel, but higher headquarters couldn't communicate orders effectively. Air defense batteries fired independently without central coordination. Army divisions waited for instructions that never came because the communication networks were destroyed. Some Iraqi officers tried using civilian phone lines to coordinate operations. American intelligence intercepted those calls within minutes. Turns out commandeering the public telephone system to run military operations makes your communications extremely vulnerable to monitoring. The Tomahawk strikes cost roughly $180 million in missiles alone. That's $625,000 per missile. Pentagon analysts later calculated the campaign eliminated targets that would have required 400 to 500 aircraft sorties to destroy using conventional bombing, sorties that would have cost American lives and aircraft losses. The cost-benefit analysis was brutal. Spend money on cruise missiles or spend lives on pilots. America chose missiles. Iraq's military never recovered from those first 24 hours. Soviet military observers watched Desert Storm with growing dread. They had analysts embedded with international media, intelligence officers monitoring American communications, satellites tracking coalition operations. Moscow saw the Tomahawk performance data in real time and understood the implications immediately. The Soviet Navy had nothing comparable. Their cruise missile programs, P-700 Granite, P-500 Basalt, KH-55, were either too large for widespread deployment, required strategic bombers as launch platforms, or lacked the precision guidance Americans had perfected. Soviet cruise missiles were designed for nuclear delivery against carrier groups, not conventional precision strikes against land targets. The entire concept was different. What terrified Soviet planners was the operational flexibility. American ships launched Tomahawks from the Persian Gulf and Red Sea without entering Iraqi weapons range. Soviet doctrine required naval forces to close with the enemy, use missiles and mass salvos, accept losses as inevitable. The Tomahawk allowed standoff engagement at ranges where counterattack was impossible. Moscow's defense ministry started emergency reassessments of their naval capabilities in February 1991. Internal documents from that period, some declassified years later, show Soviet admirals calculating how many Tomahawks the U.S. Navy could launch simultaneously if targeting Soviet facilities. The numbers were catastrophic. American cruisers and destroyers in the Mediterranean and North Atlantic could potentially put 500 or 600 cruise missiles in the air before Soviet coastal defenses could respond effectively. Soviet air defense networks faced the same problem Iraq discovered. Their radars were optimized for high-altitude bombers and ballistic missiles, not subsonic cruise missiles flying at 100 feet. Moscow had layered S-300 batteries around critical installations, but those systems needed warning time and clear targeting data. Tomahawks approaching from multiple vectors at terrain-following altitude would overwhelm acquisition radars. The Soviet Union collapsed 9 months after Desert Storm ended. I don't think Tomahawk performance caused the collapse, but it definitely illustrated how far behind Soviet military technology had fallen. Their generals watched American precision strikes and realized they couldn't replicate those capabilities with existing resources. Russia inherited the Soviet Navy's cruise missile problem. Throughout the 1990s, they tried developing equivalents. The Kaliber series eventually emerged as their answer. But Kaliber didn't achieve operational capability until 2012, more than 20 years after Tomahawk proved the concept in combat. 2 decades of technological capabilities. Chinese naval development in the 1990s and 2000s focused heavily on cruise missile technology, specifically because Tomahawk demonstrated what was possible. The global strategic calculation shifted. Before 1991, naval power meant carrier groups and submarine fleets. After Desert Storm, naval power included the ability to launch precision strikes from surface combatants at standoff ranges. Countries without cruise missile capabilities became vulnerable to adversaries who possessed them. Iraq's defeat sent a message to every potential American adversary: your air defenses are obsolete, your command bunkers are vulnerable, your military infrastructure can be systematically destroyed before your forces engage coalition ground units. The Tomahawk didn't just win battles, it redefined what naval power meant in modern warfare. Soviet military journals from 1991 and 1992 are fascinating reading. You can track the progression from initial skepticism to dawning horror to desperate attempts at doctrinal adaptation. They understood they'd been outmaneuvered technologically and couldn't catch up without resources. The collapsing Soviet economy didn't have. America had developed a weapons system that rendered an entire generation of Soviet military planning irrelevant. That's not propaganda. That's what happened. Iraq's military defeat started with those first 288 Tomahawk strikes. Everything that followed, the air campaign, the ground assault, the highway of death, became possible because Iraqi command and control was already shattered. Coalition aircraft flew into Iraqi airspace on January 17th, facing air defenses that couldn't coordinate responses, couldn't communicate targeting data, couldn't receive orders from Central Command. The Tomahawk campaign accomplished in 3 hours what traditional air power would have required days to achieve. Planners estimated destroying Iraq's command infrastructure with manned aircraft would have needed 400 sorties minimum, probably closer to 600 when accounting for weather delays, defensive losses, and missed targets. That's 400 opportunities for SAM batteries to shoot down American pilots. The cruise missiles eliminated that risk entirely. American F-117 stealth fighters hit targets in downtown Baghdad the same night Tomahawk struck. Those pilots flew into a city where air defense networks were already crippled, where communication between SAM batteries and command centers was severed, where Iraqi operators were firing blindly at targets they couldn't track effectively. The Tomahawks didn't make the F-117 mission safe. Nothing about flying combat sorties over hostile territory is safe. But they made them survivable. Iraq's Air Force never mounted effective resistance. Their fighters stayed grounded or fled to Iran because coordinating defensive sorties without functional command networks was impossible. Iraqi pilots needed targeting data from ground controllers, needed vectors to intercept coalition aircraft, needed fuel status updates and threat warnings. The infrastructure supporting those operations was destroyed before most pilots reached their cockpits. By January 20th, coalition aircraft were flying daytime missions over Baghdad with near impunity. Iraqi SAM batteries still posed threats. They shot down aircraft throughout the war. But they operated in isolation without central coordination. Individual battery commanders made targeting decisions independently, which meant coalition aircraft could predict and avoid known threats. The ground war started February 24th. Iraqi army divisions that should have been repositioning to counter coalition movements stayed in static positions because command couldn't relay orders effectively. Unit commanders waited for instructions that never arrived. When coalition armor smashed through Iraqi lines, the defenders fought with courage and determination, but without strategic coordination. Tomahawk strikes continued throughout the ground campaign. American ships kept launching missiles at emerging targets, command posts, coalition intelligence identified, communication nodes Iraqi forces tried activating, supply depots feeding frontline units. The cruise missile inventory got used systematically to maintain Iraqi command paralysis. 100 hours after the ground war started, Iraq agreed to ceasefire terms. Their military was shattered not just by coalition firepower, but by complete loss of operational control. Divisions surrendered because they couldn't contact higher headquarters for orders. Retreat routes turned into killing zones because units moved independently without coordinated planning. The Tomahawk didn't win Desert Storm alone. Coalition aircraft, armor, artillery, and infantry did the fighting. But those forces operated against an enemy already blinded and paralyzed by cruise missile strikes that started the war. Modern warfare changed permanently in January 1991. Every military conflict since then has included cruise missile strikes as standard doctrine. Serbia in 1999, Afghanistan in 2001, Iraq again in 2003, Libya in 2011, Syria repeatedly. Tomahawks became America's opening move